power generated by the turbine. And that power, what do we notice? It is a function of area. Another way of defining this area is by saying the radius of the blades on the turbine. But that is a linear relationship. It's a one-to-one relationship. Okay? The thing that actually carries the meat on the bone is the speed. Because if you look at the speed, now let's assume the speed is 1. 1 to the power of 3. It remains 1. It's not a big deal. Meaning your multiple is 1. But now let's take it and let's make the speed 2. If you say 2 to the power of 3, you get 8. Oh, your multiple went from 1 to 8. If you just double the power from 1 to 2. Now let's take the power from, let's take the power when the speed goes from 2 to 3. If it's 3 to the power of 3, it's 27. That means your multiple, it goes from 8 to 27. So if your speed is 1 meters per second, 2 meters per second, and subsequently 3 meters per second, your power output, it will go from 1 to 8 to 27. Imagine that. Okay, and that's why this is important. Okay, however, and this is actually what's key. Check this out. Once we have this, what we can also do is the following. We can rewrite it. We can rewrite it like this. Now, why are we rewriting it like this? Because this over here, this term is what we refer to now as the power density of a wind turbine. Meaning the density of a wind turbine as a function of, or as a unit of area. Okay, and we refer to this as the power density right now. This density here, it can also be written out as pressure over RT, which is just the gas constant, and then T being the what? The temperature. And this over here is what it is that we were actually trying to figure out. The power density of a wind turbine, okay, it is a function of the pressure, okay, it is a function of the speed, meaning it's directly proportional to the pressure, directly proportional to the speed cubed, okay, it's inversely proportional to temperature. Now, why is this important? Because temperature, it has an inverse correlation with our power density of our wind turbine. Okay? And this is just a means or a way of manipulating a few equations, understanding their significance or their importance in the context of a wind turbine. Obviously, these are not the final sets of or set of equations. This is just to whet your appetite as to show you what's out there. Because what people don't realize is that this year it comes from your ideal gas laws this year. But because it has a pressure and a temperature component, it can now actually also play its way into the power density of a wind turbine. Imagine that. So, yeah, that's where we will stop for now.